For this experiment, we are gonna need the following: potted plant, 2 transpirated polythene bags, rubber band, a spoon, anhydrous copper sulfate, white plate. Take a potted plant and cover it with a polythene bag. And tie its mouth with the rubber band. Expose this setup to the sunlight for an hour.
Observation. After 12 hours, we can see that drops appear inside the polythene bag. Collect the liquid droplets inside the polythene bag with a spoon and pour it to the anhydrous copper sulfate plate. We can see that white color anhydrous copper sulfate in the plate turns to blue. Conclusions. From this experiment, we can conclude that the liquid droplets inside the bag were formed due to the condensation of water vapors released from the aerial parts of the plant through the process of transpiration. From adding copper sulfate to the liquid droplets, we can confirm that the liquid which was inside bag A is water, because when there is water present in a sample of copper sulfate, it turns blue.
The material needed for this is first a piece of thread, then 2 supports to hold the thread, 4 leaves of a selected plant, and finally lip balm instead of Vaseline to apply on it.
To begin the experiment, take the 4 freshly plucked leaves. In the first leaf, apply lip balm to both upper and lower surfaces of the leaf. In the second leaf, smear lip balm only on the upper surface of the leaf. In the third leaf, apply lip balm only on the lower surface of the leaf. Leave the fourth leaf as it is without smearing any lip balm and apply lip balm on the plucked ends of the petioles. Tie the petioles of the 4 leaves with a long piece of thread as here. Suspend both ends of the thread containing 4 leaves on a stand shown here. Leave the setup in a bright sunlight for 1 day.
Now let us see the observations. Leaf A gives no change in the leaf appearance, and leaf B looks dry but not as dry as the leaf D. And the leaf C appears to be drier than the leaf A but not as dry as the leaves B and D. And finally, the leaf D appears to be the driest of all other leaves.
Conclusion. Leaf A. As Vaseline was applied on both surfaces of the leaf, the stomata on both sides are blocked from transpiration, thus holding more moisture within itself. Leaf B. As Vaseline was only applied on the upper surface of the leaf, considerable amount of stomata was blocked from transpiration. But at the same time, some water is lost from stomata present on lower surface of the leaf by transpiration. So, it holds higher moisture content than leaf D but less than leaf A and C. Leaf C. As Vaseline was applied on lower surface of the leaf, stomata are blocked only on lower surface. Because of that, some amount of water lost from the upper surface of the leaf through transpiration. As number of stomata on bottom surface is high, the moisture trapped within leaf D is higher than the moisture content remaining within leaf B, but less than leaf A. Leaf D. As Vaseline wasn't applied on the both sides of the leaf to block the stomata, so water has left due to transpiration through the both surfaces, thus has the lowest moisture content.
Overall, from this simple experiment, we can conclude that most of the stomata through which transpiration takes place in the die-cut leaves used in this experiment are distributed on their lower surfaces. These stomata, being fully covered by Vaseline, are unable to act as medium for the outlet of water from the leaves. We may thus conclude that stomatal transpiration is a major source of transpiration.